Hi, this is Chuck Shembry, environmental scientist with the Nevada Division of Environmental Protection. In this video, I'm going to conduct a soil slake test to demonstrate how the same soil type under two different management practices and soil management practices reacts under the forces of water, and how soil management practices that cause disturbance to the soil reduce the soil's ability to be resilient against the forces of water, and how soil that is more disturbed and lacks healthy soil properties is more vulnerable to soil erosion and compaction, and can also be a large source of non-point source pollution to our waters here in Nevada. So here I have two soil beds. Both are sandy loams, and they both came from the Nevada experiment station at the University of Nevada, Reno. And they're both a sandy loam. One of them here on my left came from a pasture that had been under pasture for 20 plus years, permanent pasture, very lightly grazed. Cattle would be rotated through the pasture, and very limited amounts of herbicides were sprayed on the field. Probably many years herbicides would never have been sprayed. And then this soil here on the right, which is about 800 feet away from the pasture, is a vineyard site that had been farmed, historically had many crops farmed on it, alfalfa, different crops for research throughout the decades. But in the late 90s, a vineyard was planted, and this vineyard was farmed under annual cultivation, maybe 3 to 4 discs a year to turn the soil over as weed prevention, mechanical weed management. And also herbicides were sprayed under the vine row to prevent the weeds growing under the vine. No organic inputs were put into the field. The field is very devoid of living vegetation. No cover crops were planted throughout the duration of this vineyard's life. So therefore, we understand that this soil is not as healthy as this pasture soil. This pasture soil has organic matter upwards to 5% organic matter, and this soil has organic matter below 2%. And if we just look at these two, if you can visually see here, see if I can get it focused, this soil here is lacks pore space. You can see it looks like a larger consolidated mass of fine particles, and doesn't have much complexity to the structure. There's not larger aggregation that's visible. And in this soil here, we have much more definition of soil structure. There's root systems in here, much more living matter, and we can hypothesize that the pore space of this soil, there's much more pore space. And when we put these two soils, submerge them in water in the slake test, we will see what happens to the soil and how it reacts under the forces of water. Lastly, I should note that both of these soils were collected 2 years ago from this time. So they're very dry. There's no moisture occupying the pore space. And so let's see what happens. So what we have here on the left is that vineyard soil that's been under a lot of cultivation and soil disturbance through mechanical weed and chemical weed management. And here on the right we have the fairly undisturbed pasture that's been lightly grazed, and very limited use of herbicides and very limited soil disturbance. So I'm going to place these two into these jars. Let's see what happens. As we suspected, the vineyard soil, the soil that's under heavy cultivation and disturbance, is it's falling apart. The pasture soil on the left is maintaining its integrity, its structural integrity, and has very good aggregation. There's great pore space in the soil, and so the water's been able to occupy the pore space and also percolate through it. This soil on the right, the soil particles are detaching from each other, and if this was in a field and there was a rain event, as you can imagine, these soil particles will be transported in the solution. Sorry, they'll be transported in the water as runoff, and that is often the source of sediment delivery. When soil particles are displaced so easily, because they lack the healthy soil properties, they become suspended in water much more easily, the fine soil particles such as silt and clay. And these are transported to our streams, our creeks, maybe to the ditch first, then to the stream, and eventually to the river, to the lake, or to the ocean. And again, these are the same soil type, both the sandy loam on the same geomorphological landscape. So through our soil management, we can really improve the health of our watershed. There's a lot of indication about the crop production and crop resiliency under a healthy soil management system. And also many farmers across the United States are documenting economical improvements and benefits with healthy soil practices. Well, it's been about 3 to 4 minutes. We can see how turbid the soil is in the vineyard soil. And so this is fine soil particles that are being suspended in water and solution. And this is one of the largest sources of non-point source pollution in the United States is soil or dirt that is transported off of disturbed land, bare soil. So vegetation and ground cover are so important to providing the necessary function for a healthy soil. In the pasture soil, there's always a living root system. Those root systems are habitat for soil microorganisms. They are exuding root exudates, different amino acids and carbohydrates that the soil microbes are able to feed off of. And that living root system is also providing a habitat for mycorrhizae fungi, which live in association with plants. And with that will come fungal hyphae, which are these very, very microscopic web-like strands that you can actually see with the naked eye as they're all condensed in an area. You might see it in a compost pile. But these fungal hyphae are really wrapping themselves around these microaggregates, creating larger macro aggregation, which is really important for soil porosity, water infiltration, and water holding capacity. Although in this demonstration we're using a heavily disturbed soil from a vineyard and a very undisturbed soil from a pasture, I am not saying that vineyards are a larger issue and source of non-point source pollution. This is really about soil management. A vineyard can be farmed under no tillage systems. It can have cover crops, and it can have lots of alternative soil management practices with organic inputs that could improve the soil health and reduce what we're seeing here with the aggressive, vigorous slaking.